Hi guys, this is Abhishek back again with another tutorial, and in this video we will be see how to use a BMP280 barometric pressure sensor with the help of ESP32 development board. So I have a DF robot manufactured BMP280 pressure sensor and also have a ESP32 development board. And now firstly we understand why we measure barometric pressure. Measuring barometric pressure is important for several reasons, mainly related to weather forecasting, altitude measurement, and industrial applications. In a weather forecasting, high pressure above to 1013 hectopascal usually indicates clear skies and stable weather, and low pressure below 1000 to 13 hectopascal often signal storms, rain, or bad weather. Rapid pressure drops can indicate incoming storms or severe weather. And in the altitude measurement, barometric pressure decreases with altitude sensor like BMP280 or BMP280. Use this property to estimate elevation, which is useful for drones, aviation, and hiking. And in the third application, that is industrial and environmental monitoring, used in HVAC systems to optimize airflow, helps in gas sensor calibration as gas concentration depends on pressure. Used in air quality monitoring to assess how pollutants behave under different pressures. And in the fifth application, that is very important in the marine and underwater application. It is used in diving to measure depth. Water pressure increases with depth, helps in tide prediction and oceanography studies. So, barometric pressure sensors are used in multi-purpose and multiple applications. Now we jump onto the circuit diagram how we integrate this BMP280 pressure sensors with to our ESP32 board. So in the BMP280 pressure sensors have a 4 pin, that is a VCC pin, ground pin, SCL, and HDA pin. So this DF robot BMP280 pressure sensor is operated from 3.3 volt power supply. So we connect a VCC to 3.3 volt power supply of our ESP32 board and also connect a ground to ground, and SCL pin is connected to the ESP32 SCL pin and FDA pin is connected to the FDA pin. I have manufactured a PCB. A PCB is a printed circuit board, and in the PCB we have folded the sensor and a ESP32 board. And now circuit diagram you can see on the screen. So circuit diagram is very simple, and now we jump onto the Arduino IDE. In the Arduino IDE, firstly you need to download the BMP280 pressure sensor library. So go to the library option, and in the library option type DF robot BMP280 and install the DF robot BMP280 by DF robot library. I have also installed it. After installation, click on the file, go to the examples, and in the bottom side, in the library option, examples from custom libraries, go to the DF robot BMP280 and click on the read data. So the example is open how to read the data of the sensor, and now connect the cable to your ESP32 board and to your computer, and then example is open, and now go to the tools option, click on the boards and select the board what you have chosen. I have chosen ESP32 development board because I have used this, and then click on the port and choose the right port that you have used. So our ESP32 is a POM6 port, so I have chosen a POM6. And after that, go to the tools and also erase all flash before sketch upload enabled. And now you are able to upload the code onto the ESP32 board. But uh, which people don't install the ESP32 development environment on the Arduino IDE. So go to the preference. In the preference option, enter additional URLs, one for each row. So add this URL we have given onto the description or in a comment box. So you can copy it and paste it on here and click on the OK and OK. After that, go to the board manager and in here click on to the ESP32, and now download ESP32 by Express it, and then your development environment for ESP32 is configured, and now you will be able to upload the code onto the ESP32 board. So now click on to the upload button, and the code is compiled first, and then uploading process is start. So just wait for a few seconds. So now the code is uploaded successfully, and now click on the tools and click on serial monitor and click choose the baud rate, that is 115200, and now you will be able to see the temperature unit in Celsius 21.21 degree Celsius, pressure in Pascal unit 98745, altitude 235.36. Now you will be able to detect the temperature, pressure and altitude on your environment. If you found this video helpful, don't forget to hit that like button. It really helps the channel and motivates me to create more content for you.